We are taking question and answer on motion. An athlete completes one round of circular track of diameter 200 meter in 40 seconds. So if this is the circular track, the diameter is 200 meter and it completes in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So for one round it takes 40 minutes. This is the time, so we will divide this by this so that we can get number of rounds. First we have to convert this 2 minutes 20 second into 40 second. How to do that? This 2 minute 20 second, we know 2 minutes is equal to 120 seconds. Add it with 20, it gives you 140 seconds. Since the diameter is given as 200, the radius will be equal to 200 by 2, that is radius will be 100, so radius is 100. Now in 40 seconds, one round. In 140 second, how many rounds? 140 by 40, that is 3.5 rounds. So distance covered in this 140 second is simply we multiply 3.5 by what? If this is a circle, this is the circle, the circumference will be 2 pi r. 2 into pi into radius is 100, 2 pi r. Multiply it by 3.5 because this is one circumference, but we have to multiply it by 3.5 circumference, so it gives 2200. After this, what happens? One round is like this, so it goes for 3 rounds, then 0.5 rounds. So the player or the athlete is diametrically opposite like this. So what is this distance? This is 200 meter. This is the displacement. Joseph jogs from one end A to another end B. So he jogs from A to B, and this is 300 meter. The time is 2 minutes 30 seconds. That is 2 minutes is 2 into 20, 2 into 60, 120. 120 plus 30 is 1. This is 120 seconds. Now 30 seconds you have to add. It becomes 150, and then turns around, like it turns around and goes up to 100 meter. And this is point C. Another 1 minute. So total is this much plus 1 minute. What are Joseph's average speeds and velocity in jogging from A to B and from A to C? So from motion A to B, the distance covered as we see here is 300 meter. The displacement is from A to B, which is again 300 meter. And the time is 150 second because 2 minutes 30 second is 150 second. So what will be the average speed? Because the distance covered and displacement both are same, the average speed and average velocity will also be same. How? The average speed will be total distance covered by total time, and the average velocity will be net displacement by time taken. So time taken in both the cases is 150 second, but in this case this total distance is also 300 and in net displacement is also 300. So 300 by 150, 300 by 150, in both the cases the average speed and the average velocity is going to be equal to 2 meter per second. Now when it comes to A to B and C, that is A to C, now the distance is 300 plus 100, that is 400 meter. What is the displacement? 300 is this distance, 100 he has come back. So we have to subtract these two. 300 minus 100, that is 200 meter is the net from here to here. The displacement is this, which is actually equal to 200 meter. So time taken is this much time and 1 minute to return back. So this 150 second plus your 1 minute, that is it is 150 second. This 2.5 is 2.5 minute. This is 1 minute. This is 3.5 minute. Multiplied by 60, you get 210. So what will be the average speed? In both the cases, the time taken will be 210 seconds, but the total distance covered, the average speed will be 300 plus 100, that is 400 by 120, 210, that is 1.90. But the average velocity, we use the displacement. Displacement is what? This is 200 only, as we just saw. So 200 by 210, that is 0.952 meter per second. Abdul, while driving to school, computes the average speed of his trip to 20 km per hour. Now Abdul is driving from here to here, say from home to school. The speed is 20. Now when he returns back, the traffic is less, the average speed becomes 30, so he can travel faster from here to here. So it is 30. This way, this way. What is the average speed of Abdul's trip? Now what happens here is, we know that the time is distance by speed. The distance we don't know, so let us assume this to be x. X in this way, x in this way. So it is one distance is x So what will be the time t1? X by 20. This is x by 20, t1. t2 will be, because the reverse is, the speed is 30, so x by 30. X by 20, x by 30, this is t1, this is t2. When we want the total time, x by 30 plus x by 20, the total time is 5x by 60. Now what is the distance? X. And total distance, again x, so 2x. X in this way and x in this way. Total distance travel is 2x. So 2x is the total distance. Now we know the distance, we know the time, we know how to find out the speed, which is equal to distance by time. So 2x by 5x by 60, x gets cancelled, 60 goes up, 60 into 2 by 5, which is actually equal to 24 km per hour. A motorboat starting from rest, that is u equal to 0, initial velocity 0, on a lake accelerate in a straight line. So it is a straight line and constant rate 3 meter per second square. This is the acceleration. Time is 8.0. How far does the boat travel during this time? We know the formula is s equal to ut plus 8 half a t square. U is 0, a is 3, t is 8. Just put all these value here, you get s equal to 96 meter. Now a driver of car traveling at 52 km an hour applies the brake and accelerate uniformly in the opposite direction. That is, it goes like this, then at this point it deaccelerate. You can say deaccelerate. The car stops after 5 seconds. Now the other driver who is going at 34 km an hour, in other car applies his brake slowly and stop in 10 seconds. So the other one, he goes like this, but he stops in double of the time. That is, this is 5 seconds. He stops after 10 seconds. So on the same graph paper, plot the speed versus time graphs for two cars. Which of the two cars travel farther after the brakes are applied? So first of all, this is in kilometer an hour and this is 5 seconds. So we have to, change the you can say the unit. So this 52 kilometer per hour an hour. So we will convert into meter. Then 60 into 60 for seconds. So this 52 has to be multiplied by 1000 by 60 by 60, which is giving you meter per second. So for 52, the speed in meter per second is 14.4. For 34, in the same way, if you place 34 here, the speed in meter per second will be 8.9, like this. Now, how to draw it? This is time. As we said, that this first one start with 14.4. So we draw a graph from 0 to 20. At 14.4 we start, and then it stop at 5. So we 0 to 5 will stop it. The second one starts at 8.9 and then it stops at 10 seconds. So we'll select this 10 and this 8.9 and join this. So these are two triangles and the area of the triangle is the distance traveled. So how to find out the distance? See, we'll take the first triangle, which is actually A, O and B. What is the area of the triangle? Half into base into altitude. That is half into AO, this one altitude into base. So half into AO into BO, we know that 52 can be converted like this into meter per second, and this is second of, to course, this one, 5. So this is 36.1. Now we come to this triangle, COD, this triangle. Half into CO into DO, that is half into 34, this has to be converted into meter per second. And this again is from here to here, it is 10. Half into 34, this 34 converted into meter per second into 10, which is equal to 47.2. So in this case, we see that this 47.2 is higher than 36.1. So the second car traveled farther than the first car after they applied the brakes. In this, this graph shows the distance time graph of three objects A, B and C. Now study the graph and answer the following question. Which of the three is traveling the fastest? See, at the same point, at the same means you can say the distance or because this is the distance traveled by B is higher than either of C and A. Though C and A are taking more time, and in a lesser time, B has reached a higher distance. So B is traveling the fastest. Are all three ever at the same point on the road? No. If they would have intersected at the same point, we would have said, okay, they might have at the same point on the road, but it is not. How far has C traveled when B passes A? When B is passing A, that is B and A intersection. Where C is at this point, C is at this point. So around, some 6 values there or 7 values there. How far has B traveled by the time it passes C? So B and C intersection point is this. We have to find how far B has traveled after it passes C. So this distance around 7 or 6 is there. So this is how B is traveling faster. All three are never at the same point, and approximately 6 and 7 kilometers are the answer. You can find it like this. A ball is generally dropped from height 20 meters. So the distance is 20 meters, and because it starts from 0, u equal to 0, if the velocity increases uniformly at the rate of 10 meter per second square, this is the acceleration. With what velocity will it strike the ground? We have to find out the velocity, final velocity, v equal to what? At what time will it strike the ground? So we have to find the t also. So we have two formula, v square is equal to u square plus 2as, and the second is v equal to u plus at. So let us start this. We know u equal to 0, s is given as 20, a is 10 meter per second square, which is acceleration. V square minus u square equal to 2as will use, and we'll find out the v. This is v equal to 20. Now we know v equal to u plus at. We'll just rearrange it to find out the time. We know the value of v minus u, which is 20, and a is of course 10. 20 by 10 is 2 seconds. The speed time graph of car is shown like this. Find how far does the car travel in the first 4 seconds. Shade the area on the graph that represent the distance traveled by the car during the period. So this is the time, 4 seconds, and at 4 seconds what is the distance traveled? So this is 6. Actually it is 6. And what is the, because this is time and speed, so 6 is the speed, time is 4 seconds, and now this whole area has to be shaded, and half into base into altitude. Altitude is 6. So this will be the distance traveled. Which part of the graph represent uniform motion of the car? See, after 6 seconds, the car has a uniform motion, means the speed is uniform. So after 6 seconds. So as I just suggested, distance is half into 4 into 6, that is 12. This is 4, this is 6. Half into base into altitude is the distance, and this is the shaded region. And after 6 seconds, the car moves at uniform motion, that is the speed 6 meter per second. State which of the following situation are possible and give an example of each of the following. An object with a constant acceleration but with zero velocity. So see, if you throw some object or a ball, it goes like this. At this point the velocity is 0, but still gravity is there, so acceleration is constant. And an object moving in certain direction with an acceleration in the particular direction. So what is happening here is, if the object is moving like this, there is a perpendicular direction acceleration, which is the gravity. It is also a case, you can give example like this. An artificial satellite is moving in a circular orbit like this. The radius is this one. So calculate its speed. We need to calculate the speed. The time is given as 24 hours to revolve around the earth. So we are being given various things because the radius is given, and we know that this is the 2 pi r. 2 pi r will be the circumference. So we'll find out the distance like this. We have time, so we can calculate the speed. So radius is this. You can even either convert it into meter, or you cannot. You don't want to. You can keep it in kilometer only. Time is 24 hours. You can even convert it to seconds. 24 into 60 into 60. You don't want. Let it be like this. We know that speed is equal to distance by time. In this case, distance is 2 pi r. This is 2 pi r. So we'll put the values, divided by this value. This is 3070.9 meter per second. Why we converted it? Because the calculation will be easier. If you divide it by 1000, you will get it in kilometer per second. These are question and answer on motion. Thank you so much. Take care of yourself.